All right, this is 7-6. It's exponential growth and decay. If you have highlighters or colored pencils, this is be a really good one to use those highlighters or pencils on because I'm going to be highlighting a whole lot. All right, so first we're going to start with exponential growth. Okay, so growth, if you look here at this formula, whoops, that's not what I wanted. If you look here at this formula, okay, this is what we're going to be working with today. There are three variables that we're going to be looking at. We're going to be looking at A, which everything that has anything to do with A is going to be yellow. Anything that has to do with this R is going to be red. And anything that has to do with T is going to be blue. Okay, so let me zoom back out. Right here, it says A is your initial amount. So A right here is my initial amount. Okay. The R, which is going to be my red, is the rate of change expressed as a decimal. And then T is going to be my time. This stuff's not really that hard if you do plug stuff in. The difference between growth and decay, growth has this plus sign. In the equation, decay has a minus sign. So if you follow along, you're going to do pretty good. Okay, I'm actually going to work through this example with you, and then we're going to do, I think, just one. We're going to do two examples, and then we'll go on to decay. Okay, so for exponential growth, let me go ahead and work this first one out. Lots of highlighting, okay? It says the population of Johnson City in 2005 was 25,000 people. So here's my initial amount, 25,000 people. So I'm going to highlight that yellow. Since then, the population has grown at an average rate. So remember, rate is my red, of 3.2% each year. Write an equation to represent the population of Johnson City since 2005. So again, what they did is they had, you cannot have the rate is going to be in a percentage. In your problems, you have to put it as a decimal. So that's why they took 3.2% and wrote it as a decimal. So here's my R for my rate. Here is my rate. Okay, and then the other information they gave us was the initial amount. So here's my A. My initial amount was 25,000. So there stayed 25,000. What they did to get this right here, which I'll use green, is they just added the 1 plus the 0.032. Both of them though are going to be T. Both of them though are going to be to the power of T. Okay. And so now here for part B, it says according to the equation, what will the population of Johnson City be in 2015? So in 2015, okay, this is going to be part of our time because we're talking about years. So what they did is they said, okay, so let's figure out how many years this is. From 2015 to this 2005 up here, you're going to subtract, you get 10. Okay, so 2015 minus 2005, that gives us 10 years. So what we're going to do is they substituted right here, this little 10. That's what they plugged in for T. So again, okay, they still have the initial amount, which was 25,000. This 1.032 that I highlighted in green earlier, okay, that was adding the 1 to our rate. And then they did the blue, which is T or time, that was 10. And so they plug this stuff in, and you get about 34,256. So now let's go ahead and do a problem. Okay, it says in the United States, the population of the United States has been increasing at a rate. So I'm going to get my red, of 0.91%. Okay, what I'm going to do right now is I'm going to write this as a decimal. So to do that, let me go ahead and zoom in. To do that, okay, you have to move the decimal point over 2 times. So what I'm going to get for my decimal is 0.0091. All right, so my rate is ready. It says if the population was about 303 million, so, and on. So let me go ahead and highlight that because that's my initial amount. So here's my initial amount in 2008. So here we're talking about time. Predict the population in 2012. So again, we're talking about time. So what we're going to do is we're going to first write about this time. Let me zoom in again. Okay, so you're going to look at your paper because I'm going to zoom in to write this to make it fit. So my time is going to be equal to the difference in the years. So I have 2012 minus 2008. So that gives me 4 years. So my time is 4. The other thing that I have, I'm going to use orange here so it looks a little bit better than yellow, is my A, which is my initial amount. So that's at 303 146,146,000. And then the other one was my rate, which I wrote as a decimal, and my rate is 0.0091. So what I'm going to do, and again, y'all can always slow this down, rewind, pause it, whatever, is I'm going to plug this into my equation. So we have y equals, okay, I can go and look at my equation. My equation is y equals a times 1 plus r to the power of t. So we're going to go ahead and plug in what we have. So I have y equals, my initial amount, okay, was 303 million. So let me write that out. 146,000. Okay, and then it's going to be parentheses 1 plus my rate. My rate was 0.0091. And that's all to the power of the time, which my time here was 4. Okay, you can put all of that into the calculator and you'll get your final answer. So y is equal to, it should come out to 314,333,2051.4. Big number here. So about 314 million. All right, and that's it. That's your final answer. Okay, second one like this for your growth. Okay, so here we go, second one. It says population. It is estimated that the population of the world is increasing at an average rate of 1.3%. So I'm going to go ahead, I'm going to highlight that, and I'm going to go ahead and write that as a decimal. So let me zoom in. Okay, I'm going to write this as my decimal. Remember, you got to move this over twice. So it's going to be 0.013. So there's my decimal. If the 2008, so there is my time. So I'm going to go ahead and highlight that. Was about 6 billion. That's 6 billion. So I'm going to go ahead and highlight that because that's my initial value. It says predicted for 2015. So I'm going to go ahead and highlight this because that has in blue because that has to do with time. All right, so we're going to go ahead and start with time first. So let me go ahead and zoom in so I have space to write. Okay, so my time for this one, we're trying to figure out from 2015 and 2008. So my time here is going to be 7 years. Okay, my initial amount, I'm going to write it in orange so you can see better. So A is equal to, is that 6,641, and so 1, 2, 3, 1, 2, 3. And then the last thing I have to do is my rate, which was my R, and I wrote that down as 0.013. Okay, so I'm going to come over here, I'm going to write my equation. So my equation is y equals a times 1 plus r to the power of t. Okay, so we have y equals my initial value. So my initial value, I'm going to write it in orange, was 6,641,000,000. Parentheses 1 plus my rate. My rate was 0.013, and that is going to be to the power of 7. Okay, so I'm going to put that in your calculator, and when you hit y equals, you'll get close to 7,269,417,259. All right, so the last little section here, okay, is going to be decay. So if you notice here is the exact same thing. So we're going to use the exact same colors. The only difference is instead of a plus sign, right here you have this minus sign. Okay, so let's go ahead. I'll look at the first example with you so you can kind of see the same stuff. Follow along. So I'm going to just work right out into the examples. Oops, did not mean to do that. Okay. So number 1, it says the population of Bulgaria has been decreasing at an annual rate of 0.89%. So what we're going to do here is we are going to write, or highlight, I mean, in red. There we go. It's 0.89%. And I'm going to go ahead and zoom in and write above it as a decimal. So I'm going to carry over 1, 2. So we have 0.0089. So there's your rate. You're done with that part. If the population of Bulgaria was about this, so that's my initial value. So let me highlight that initial value. Oh, that's not highlight. Highlight my initial value in the year 2005. So there's my time. So I'm gonna do that in blue. Predicted in 2015. Okay, so just like the other ones, go ahead and zoom in. First, I have time. So I'm gonna do blue. Time is gonna be equal to 2015 minus 2005. So that gives us 10 years. Okay, A of the equation is your initial value. So my A was the 7,450,349. And then the last thing is my rate. That's what I wrote in a decimal. So my rate is 0.0089. Okay, so then I'm going to go ahead and write my equation. So my equation here is y equals a1 minus r to the power of t. So y equals, again, your initial value, which was 7,450,349. Then we have a parentheses 1 minus my rate. My rate is 0.0089. And that's all to the power of 10. So close my parentheses, power of 10, because that's how many years we're looking at. Type all that into the calculator, and you'll end up getting y is equal to 6,813,203.776. So your answer is around 6,813,204 people. All right, next one. So Mr. Gossel is a machinist. He bought some new machinery. Where was it for? About $125,000. So again, okay, that is my initial amount. He wants to calculate the value of the machinery over the next 10 years. So there's my time, 10 years. If the machinery depreciates at the rate of 15%, so depreciates at a rate of 15%, so let's see, where was my 15? There's my 15%, so I'm going to go ahead, highlight my 15%, highlight 15%. Let me go ahead and write that as a decimal. So you have to move this over 1, 2, so my decimal is 0.15. Okay, can zoom out a little bit. Per year, what is the value of the machinery to the nearest 100 at the end of 10 years? So this one first, because I'm getting the habit of doing it, I'm going to write my time. So let me zoom in a little bit. So time is 10 years. My initial amount, okay, was $125,000. And my rate is 0.15. So again, I know this is using the minus sign, the decay, because it says that it depreciates. So what I'm going to do is I'm going to write my equation. So I'm going to go over here, and I have y is equal to a1 minus r to the power of t. And again, it's depreciating, so that's why we use the decay. So y is equal to, my initial value was 125,000. Okay, so 1 minus my rate, which my rate was 0.15. Yeah, 0.15. Okay, and then that's to the power of 10, because that's how many years that I have. And this one, I'm going to have to put this in the calculator real quick, because I'm not sure exactly what this answer is. So let me put this in the calculator. Give me 1 second, which you can be doing this too in your calculator. I know you'll probably beat me. Okay, so we have 125,000. Okay, and then parentheses 1 minus 0.15. And that's to the power of 10. So that will give us, let's see, 24,000. So $24,609.30. Okay, so that's it. All right, and the last one that we're going to do. Okay, so the last one, A new car cost $32,000. It says that it's expected to depreciate 12% each year, depreciate 8% after that. Find the value of the car in 6 years. So this is two parts, okay? So let's go ahead and first highlight all the stuff I need to do. A new car costs $32,000. So here's your initial price. Okay, that's our initial amount. Then it says it is expected to depreciate 12%. So here's my rate at 12%. Okay, what I'm going to do is I'm going to rewrite that. So let me rewrite 12% as a decimal. So 12, so 0.12. Okay, for each year for 4 years. So here's my time. Oops, let me get that blue. There we go. For 4 years. Okay, and then it says depreciate 8%. So here's the second rate. Okay, so I'm going to go ahead and highlight that. And I'm also going to write that out. So 12, so 0.08 each year thereafter. Okay, and then it says to find the value of the car in 6 years. So here's going to be my blue for time. All right, so let's go ahead. There's two parts to this. So I'm going to go ahead and do part one. So part one. Okay, so what we have to do is we're going to fill this in. It's depreciating, so we're going to do our minus sign. So I have y equals, my initial value was 32,000. Okay, so then I have 1 minus my rate. Well, the rate for that first part was 12%. So I'm going to put here 0.12. Okay, and that's going to be to the power of, it says it does that for the first 4 years. Okay, so put a 4 up there. So what you get for this first one, type that in, you're going to get $19,190 and about 25 cents. Okay, part two, what we're going to do for part two, whoops, that did not work, part two. Okay, so we have y equals, now we're going to use that as my initial amount. Okay, so the answer that we just got, that's the initial amount, so $19,190.25. Okay, we're going to do 1 minus my rate, which was 0.08. And let me erase that because I used the wrong color. Okay, 0.08, and that would be to the power of each year after for 6 years. So that's just 2 more years we're looking at. Okay, because remember it says the 6 years total. So we already used up 4 of them. We only have 2 more left. So when you type this in the calculator, it's going to come out to be $16,242 and about 63 cents. And that's your final answer. All right, and that is it for your 7-6 notes.